5, 4, 3, 2, 1, 0, and boom. All right, so we have 3 questions coming together, all based on one particular statistical diagram, which I will not be reproducing in this instance. So in this case, make sure that you have the paper on hand, make sure that you have the diagram on hand so that you could follow the explanation in the video while you're looking at the diagram. Okay, so the first question says, what is the frequency of the median weight? Now, the nice thing about this question is that you have all the weights written across in ascending order, which is the first thing that you have to do anytime you're trying to find the median. So anytime you're trying to find the median, the first thing to do is to write all your data in ascending numerical order. So as you have it here, you have 9.8, 9.9, 10, 10.1, 10.2, 10.3, 10.4, 10.5, 10.6. Good. So they took care of that for us. We didn't have to rearrange anything. Now, the other nice thing about this question is that you have 9 weights. So if you have 9 weights, then the median weight will obviously be the one in the middle. In fact, the median weight is always the one in the middle. But if you have an even number, then you'll have 2 in the middle, in which case you'll then have to find the middle of the middle then, so to speak. So for example, if you had 4 measures, then you have these 2 in the middle, then you had to find the average of these 2 to get something split straight down the middle. If on the other hand you had 5, 1, 2, 3, 4, 5, then this here is a median because it is directly in the middle. You have 2 on the left and 2 on the right. So in this case, because we have an odd number, as is the case here, in the case of 5, we have an odd number which is 9, then the number in the middle dead set would be a median, which means that you'll have 4 on the left, 4 on the right, and the number in the middle. So in that case, it'll be 1, 2, 3, 4, 5. So your median weight will be 10.2, the frequency of which would be 12. So the answer for this first question is answer C, 12, right? But let me just take a little detour here just to talk a little bit about the actual formula for finding the median. So if we have n number of measurements and we want to find the median of those n number of measurements, then the median is the n plus 1 over 2. In other words, the position of the median is given by n plus 1 over 2, or in another way of saying it, we can say that the median is the n plus 1 over 2 th term, right? So the position is given by n plus 1 over 2. Let me just leave it at that. Good. So in the case where n was let me go with 5 here to make the point. Here n is 5. So the position of the median here would be given by 5 plus 1 over 2, which is 6 over 2, which is equal to 3. So the third measurement would be a median. 1, 2. Look at right here. 3. And odd. If you have an even n, which in this case is 4, then the median will be, in this case, coming down here now, 4 plus 1 over 2, which will be equal to 5 over 2, which will be equal to 5 over 2 we know as 2.5. So in other words, because your n is 2.5, what you would need to do is find the second measure and the third measure and find the arithmetic mean, otherwise commonly known as the average. Find the average of these 2, and that will give you what we could call this 2.5 term then, so to speak. Good? And that's basically it. So in this case where n is equal to 9, right? If we want to use the formula, then if n plus 1 over 2 gives the position of the median, then in this case the position of the median will be given by 9 plus 1 over 2, which is equal to 10 over 2. 10 over 2 is still 5. So the fifth measure is a median, which in this case 9.8, 9.9, 10, 10.1, 10.2. So the median weight is therefore 10.2, which if you go across to look at the number of packets, the frequency is 12. So that's the answer C. Alright, so we want to know now how many packets were weighed. How many packets were weighed? Alright, I should have had to cut that. Whew. Yeah, because we need some space. Alright, so we are in another question. Alright, so we are on the next question here. How many? Alright, so we're on the next question here. How many packets were weighed? Now, all we have to do is look for each weight. We look at the frequency and we add up all the frequencies. So for 9.8 kilo 5, 4, 3, 2, 1, 0, and boom. Alright. So, next question. How many packets were weighed? So, we have the number of packets on the left side on the vertical axis. So, all we need to do is look at each weight from 9.8 straight up to 10.6. Look at the frequency for each of them and add the frequencies as we go along, and that will give us the total number of packets. So, just for the sake of explanation, let us say we have 9.8, 9.9, 10, 10.1, 10.2, 10.3, 10.4, 10.5, 10.6. Good? So 9.8, we have a frequency of 2. 9.9, we have a frequency of 6. 10, we have a frequency of 8. 10.1, we have a frequency of 14. 10.2, we have a frequency of 12. 10.3, we have a frequency of 9, that's between the 8 and the 10. 10.4, we have a frequency of 4, yes, 10.4 frequency of 4. 10.5, we have the same frequency of 4. 10.6, we have a frequency of 6. So when we add all of these, this will be the total number of packets weighed. How many packets were weighed? Of course, again, you do have the calculator. Alright, so for those of you who like to use the calculator as a crutch for everything, part of the psychology, if you want to call it that, of the multiple choice exam is that you don't have the calculator as an option. So you have to do your arithmetic. So you have to add it. You have to add it. You don't have a choice. Alright? So 2 and 6 is 8. 8 and 8 is 16. 16 and 14 is 30. Take a little extra time to do it if you need to. 30 and 12 is 42. Right? 42 and 9 is 51. 51 and 4 is 55. 55 and 4 is 59. 59 and 6 is 65. So your total here is 65. And if you want to double check, you could add it up as well. 6 and 4 is 10. 10 and 4 is 14. 14 and 9 is 23. And 12 is 35. And 14 is 49. And 8 is 57. 57 and 6 is 63. And 2 is 65. So you could double check to make sure you get it correct. Right? You don't want to lose marks in something like this. because you didn't add it correctly when there's something you could do. Good? The next question. Okay, so the answer for that is answer C, 65. Good? The next question. What is the modal weight? The modal weight is simply the weight that occurs most frequently. Good? So, alright. We can do that over 1, 2, 3, 4, 5, 6, 7, and boom! Alright, so the following question: how many packets were weighed? So, this part of the question now is where we get into your test of your ability to read the graph. This is what this part of the question is testing. Good? So you have the packets on the horizontal axis as the x-axis, and then you have the number of packets on the y-axis as the vertical axis. So you're looking at each weight and you're going across to see what is the corresponding number. So for example, if we could put it in a table here just for the sake of explanation, right, and illumination, illustration, so to speak. Good? The 9.8 kilograms. 9.8 kilograms, the frequency is 2. 9.9, the frequency is 6. 10, the frequency is 8. 10.1, the frequency is 14. 10.2, the frequency is 12. 10.3, the frequency is 9. 10.4, the frequency is 4. 10.5, the frequency is 4. 10.6, the frequency is 6. Alright, so pay attention most closely to your 10.3 and your 10.3. Reason being, all of these are even numbers, and if you notice the graph on the left side on the horizontal axis, they are all even numbers, but you have 9 here. How we get this 9? Your 9 in the case of 10.3 is midway between the 8 and the 10 if you look at the graph carefully, and that is how we get 9. So that is what they're looking for in this question. The rest are pretty straightforward because they lead directly to numbers that are actually on the axis itself. So after that, the rest is just simple addition, which you will have to do manually because you don't have the calculator in the multiple choice exam. So 2 and 6 is 8, and 8 is 16, and 14 is 30, and 12 is 42, and 9 is 53, and 4 is 53, and 4 is 57, sorry. 57 and 4 is 57 and 4 is 61. Okay, we did something wrong here. Let me try that again. Right? 2 and 6 is 8. 8 and 8 is 16. 16 and 14 is 30. 30 and 12 is 42. And 9 is 53. And 4 is 57. Lord have mercy. Okay. I think we need to take a break here. Boop. Five, 4, 3, 2, 1, 0, and boom. So therefore, the answer to this question is answer C. Now, the next question, where they ask for the modal weight, we know that the mode is simply the value that occurs with the highest frequency, the value that occurs the most times. That is pretty straightforward. In this case, we'll just look at the highest towers and the highest tower, the highest, what you were looking for. The tallest one in the graph, right? Which is clearly 10.1, which has the highest frequency of 14. So your mode is clearly 10.1 kilograms. Now, let me go a little extra on this question, especially for the paper 2 context, where you could get the same question, and instead of just asking for the median or the mode or the total number of packets, they could actually ask you for the mean or the average of, in other words, the average weight of all the packets. So in this case, if we have the same table, let me call this X, where X in general is any weight, and we have the 9 values here, and I will call this F, where F is the frequency for each weight. Good? So 9.8 2 times, 9.9 6 times, etc., etc., etc. In this case, if we're trying to find the mean, you need to multiply the values by the frequency. So then you'll have a separate column here. This will be the XF column, right? So 9.8 by 2 will give you something. 9.9 by 6 will give you something. 10 by 8 will give you something. 10.1 by 14 will give you something. 10.2 by 12 will give you something. 10.3 by 9 will give you something. 10.4 by 4 will give you something. 10.5 by 4 will give you something. 10.6 by 6 will give you something. That something would be the sum of all of the X by F's. Good? So this XF plus 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 this XF, where XF is simply the value multiplied by the frequency. When you add all of these, that's what you will get, whatever it is, right? We're not going to go through that in this video. So your mean then would simply be, let me call it mean, X bar would simply be the sum of XF over the sum of F, which is this fellow here. The sum of all the frequencies is a fancy way of saying the number of measures, number of measurements, which in this case is 65. 2 of the 9.8s plus 6 of the 9.9s plus 8 of the 10s plus 14 of the 10.1s plus 12 of the 10.2s plus 9 of the 10.3s plus 4 of the 10.4s plus 4 of the 10.5s plus 6 of the 10.6. All of that add up to give you 65. So if you have a case like this, where you have measures and each measure occurs with a particular frequency, then the average, which we write as X bar, X with the bar on top, will simply be the sum of the product of X and F over the sum of all the F's, and that will give you a mean, whatever the value is. You could work that out as a separate exercise just to give yourself a little practice in this kind of calculation to deal with a possible paper 2 context.